Hello! This is the second and more interesting part of my tutorial about how to set up a minimal DevOps environment. In this part, we will configure Docker and Kubernetes integration with PyCharm. Then we deploy a Docker container which performs all CICD related tasks. We have to store our build Docker images somewhere for Kubernetes deployments, so we will also install and configure a local Docker registry. Let's add these two plugins to PyCharm to enable Docker and Kubernetes integration. Go to File, Settings, click to Plugins, then install Docker and Kubernetes. Docker is installed on our server. Let's connect to that instance. Click Edit Configuration and choose TCP socket connection. Fill the engine API URL. By default, this URL is not available. We have to modify the configuration of our Docker instance. Edit the service file and add the following section to enable remote access on that port. After that, don't forget to reload the configuration and restart Docker service. So let's edit this file. I have already modified it. You can see the port was added. When you are done, reload the configuration and restart Docker service. Now we can check if the port is open and Docker is listening on that port. Very good. We can also check the IP address to be sure that we connect to the correct one. We are done. So let's connect to the Docker instance on our server. Great. You can see containers, images, volumes, everything. Let's continue with Kubernetes. The plugin uses the default configuration file in your home folder. You can find how to generate this configuration from K3S in the previous video. Double check the IP address of your server. If everything is okay, you can connect to the K3 cluster and check the nodes, workload, network, storage of your cluster. It's time to prepare our CI/CD pipeline. What does it mean? Continuous integration and continuous delivery deployment is the automation of application development. It helps for the development and operations teams working together in an agile way. Continuous integration is for the development part. Builds, tests, merges the changes. Continuous delivery and continuous deployment is for releasing and deploying the changes to the different stages, like test, acceptance, finally to production. Central and shared repositories are used for both parts of the CI/CD process or pipeline. There are a lot of tools on the market to support this process. Maybe the most popular open source product is Jenkins. You can create your pipeline, write script for the steps of the whole process. You also get a nice graphical interface. Another popular product is GitLab, with a lot of features, but these products are quite heavy. You have to deploy them separately, you need to install a server and multiple agents to build your applications. You also have to configure, administer, and back up the pipeline's related configuration. They are good for the enterprise usage, but too heavy for learning the basics. Let's try something else, something very simple. We have a server with Docker, K3s, and Git. We also have a workstation with an IDE, so we can interact with our CI/CD environment. Interaction means pulling and pushing source code from to our Git repository. But we also have to set up our CI/CD pipeline. This will be easy. Just a Docker container with a build script. We deploy this to the Docker with the help of a Docker file, and it will take care of all build and deploy tasks. And how does the CI/CD container work? It pulls the changes from the Git repository periodically or by a trigger, then run the build script and pushes the new Docker image of our application into our Docker registry. From the registry, K3s pulls the newly created image based on the deployment descriptor, and finally, our application will run in a pod in Kubernetes. Okay, we know the theory, so let's configure all of these things. You can find my source code in GitHub, so you can simply clone it, edit a couple of things, and start using it. Our application is very simple. This Docker file creates a container from Alpine Linux and writes this text to the console. We can try to deploy it to our Docker. Run the Docker file and you will see the build process. When it's done, you will see the desired output on the log tab and the container we have just built. Good. Now create a user for our CI/CD pipeline, so it can clone our Git repository and fetch the changes. Create an SSH key pair and don't forget to enable public key authentication in your SSHD configuration. You should also restart SSHD service after this change. Now we install docker-registry for our Docker images. We also need an account for our CICD pipeline. To enable this registry for K through S, we have to add it to this configuration file. We have to add this user to the registry and create a password. We have to restart the docker-registry service to see the changes. By default, this registry would need HTTPS, keys, certificates, but let's start with an insecure registry. It's a test environment. We don't need to secure it at the moment. Modify this configuration file and define that this is an insecure registry. Now it's time to deploy our CI/CD container with our CI/CD pipeline. There are instructions on GitHub how to run it. We will use the Docker in Docker use case, because our CI/CD container running in Docker will build another Docker image. This approach is quite common for CI/CD pipelines. We will simply bind our host Docker socket into our CI/CD container, so it will use Docker instance of our server. Before running this Docker file, edit the configuration and add this bind, so it will mount this file to our container from the host. Now you can run the Docker file. You see the build process and the new container. The container started logging. You can see in the Docker file that we prepare the operating system, update it, install some packages, tools. Then we add the SSH key of our CI/CD user. We add Kubernetes config, our build script, some logging, and schedule our build script to run in every minute in this cron tab. In the meantime, the build script started up and closed the repository, builds the new image, runs it, deploys it to Kubernetes, and this iteration is done. You can see in the log the steps of the build. We built the image, tagged it, pushed it to our repository, run the container just to see if we get the desired output. Then we deploy it to our Kubernetes cluster. That's amazing and simple. Now another iteration started, but there were no changes, so it finished immediately. Let's talk about our build script. To keep it general, we can define our project at the beginning and use this variable later. In this way, the script can be reused easily for other projects. The build process could be long. It's a good idea to introduce some kind of locking mechanism, so there are no conflicts and the new execution won't disturb the previous one. Then we have to check if we have already cloned a working copy of our Git repository. If not, then we clone. If we have one, just pull the changes. The most important part is build. Here you can see the steps of our CICD pipeline. We log in to our Docker registry, then build our hello world Docker file in the source code. We take the image and push it to the registry. You can run it just to test it, but it's not necessary. You can also check our Kubernetes nodes. This is optional too. Then the final step is to apply deployment descriptor to Kubernetes, which instructs Kubernetes to pull and deploy this image into a pod. After the build process, we remove the lock and refresh the build script. Let me show you this deployment descriptor. It's also very simple. Instructs Kubernetes to pull the image and deploy it to a hello world pod. And that's the whole setup. It's very simple and cheap. You need only a Raspberry, a virtual machine, or an old server. But the best thing is that you have everything in one Git repository. Your application, your CICD container and pipeline. So it's very easy to deploy, redeploy, recreate. Thank you for watching.